Right, just a quick video on the Seek Thermal again. Some guys over on the EV blog forum have noticed that when you point this thing at just a completely flat surface, I'm just pointing this down the table, you get quite a noticeable thermal gradient across the display, which shouldn't really be there. I mean, it sort of corresponds to about 4 or 5 degrees C, which is quite significant. So sort of various theories about what this might be, so I thought I'd do a little bit of investigation. Incidentally, the reason I've got the cable on here, if you are messing around with this thing, word of warning, the flex from the USB, that normally sits like that, so the flex isn't subject to bending, but as soon as you take this out, it's quite easy for this to bend at quite a sharp angle, and it actually snaps the tracks off of there. So if you are going to mess around with this thing open, I'd very strongly suggest that you I think probably either put a bit of glue at that joint or a plastic stiffener just to prevent this bend happening. Otherwise this flex is not going to last very long, and you'll have to run the thing on a cable like I am. If you do snap this flex off, I think it would actually be fairly viable just to solder some wires onto there, some sort of really thin wires down to the PCB, so I don't think it would be completely fatal, just rather annoying. So I mean, the theories are, is this down to the sensor or the lens, or maybe a sort of thermal gradient across the board or something. Now this this shows up straight from cold, so I don't think it can be a thermal gradient, because obviously there's some suggestion that maybe you've got the processor here, you've got the a linear regulator over here, which may be producing some heat, producing a sort of thermal gradient across the sensor. But literally I plug this straight in from cold and you get the gradient straight away, so it's clearly not that. And if we actually look at the board, this has been running for about 5 minutes now. We get there's only sort of 2 minor hotspots as the processor at about 34 degrees, and there's that linear regulator which is about sort of 30 versus a sort of 29. So there's hardly any gradient. Certainly the whole area around the sensor looks very flat. There's no real obvious signs of any gradient. So the so that linear regulator is the only thing that's any closer. That's only passing about 10 milliamps or so. So the it's dissipating sort of 25 milliwatts or thereabouts. So that looks like a pretty flat thermal profile on the PCB. The PCB's probably got, it's only got a ground plane. It may well have inner layers as well, which would help to keep it stable. Again, if we look at the other side, it all looks fair. So we've got that heat from the processor. Obviously although the coil's operating continuously, that's not getting hot because it's only passing a couple of milliamps. It's possible there might be a little bit of heat from the sensor, but I can't actually see anything on the sensor. You've got the shutter in the way there. Can't really see any obvious signs of anything hot inside there, so I think we can probably rule out thermal gradients over the board for this, primarily because it does it from cold. So any thermal issue would take a little bit of time to start happening. Now this has been running for a while, it's actually sort of got a bit worse. We've got so probably the easiest thing to try is just to take this this shutter off and see what difference that makes. There's a little bit of fiddle because the shutter actually sits in there. I think what they do is they probably put the shutter on and then glue the lens on afterwards, but if you're careful it can be got off. Say the connections are pressed on the board, so what I normally do is just actually push the pin through to release it. This one's been on and off a few times, so it's getting quite loose. And then you just got to sort of, if you actually pull the shutter open, it just gets it a little bit further out, and you can generally wiggle it out. It does bend the shutter a little bit doing that, but it doesn't seem to be too bad. So we'll just run this with the shutter out. Right, so now with the shutter out we can see that gradient has almost completely disappeared. We've got either 1 or 0 degrees difference across the screen. What I think is quite noticeable with the shutter knot there is that in between the calibration period it does actually get quite noisy. It's particularly noticeable when it starting up from cold, but even just when it's running and fairly stable. This is probably still trying to calibrate it every couple of seconds, or thinks it is, but there's no obviously there's no shutter there. But also if you actually give it a slight temperature gradient, if I just gently blow on it, blowing on the back of the sensor with a spray can, it gets extremely noisy between calibrations, which suggests there's probably a pretty major sort of pixel to pixel difference, which is why they really need that shutter. If I give it a real blast of freezer. So if you give it a quick blast with freezer, it just goes obviously completely nuts. But again, it's interesting that how noisy that image appears on a sort of sudden temperature change. So it would maybe imply that there's a pretty huge difference in gain from pixel to pixel. Because on a sort of, if all it was doing was correcting for offset, you'd expect the whole thing to shift. Now, so we are getting some gradients here, but that's obviously because if we're just spraying it with freezer, we are going to be creating an artificial sort of thermal gradient across the sensor. So, for example, there. The other thing that's interesting is that the blockiness of this seems to be quite a lot bigger than the claimed resolution of the sensor. Now, something that, again, on the EV blog sort of noticed on some of the raw images that were going over USB, there's some suggestion that maybe they were doing something clever by embedding reference pixels throughout the whole image, just because of sort of some regular patterns that were being seen. So I wonder if there's something like that going on. But certainly, if you look at the blockiness of that image, that certainly doesn't look like the sort of 150 by 200 odd resolution. So I think there might be something clever going on with sort of local pixel calibration or something. Right, now if we take a close look at this shutter, on first sort of glance it appears that it's almost got a curved surface, but actually I don't think that's the case. I think what we've got is just sort of leftovers from the machining marks from the injection mould. It's probably a bit hard to see on this on the video. It's quite hard to get it in focus and get the light at the right angle, but there are actually some sort of machining grooves on there. So my best guess is that what's happening is that those marks are altering the emissivity of the shutter, so what should be flat is actually sort of not quite flat, and so it's effectively getting the calibration wrong. Right, so what I've now done as an experiment is taken a paper label, just covered it in permanent marker to make it black, and just stuck it onto the shutter, so hopefully that should provide a slightly flatter reference image. Let's just see if that makes a difference. And interestingly, that doesn't actually seem to have made any difference. So it probably isn't the surface texture of the shutter, but it is something to do with the shutter. So if it's not the shutter surface, I wonder if it's something to do with the position or the timing. Now, one thing I did notice, if I just push it manually, the image does move across in the same direction we were seeing on the gradient, so it's in the same axis. What I've done is I've just disconnected one end of the coil and just connected a couple of bits of wire onto it so I can manually interrupt it, just in case it's something silly like the timing isn't right. So if I just disconnect the shutter, so this is basically the shutter is now completely closed all the time. Again, we see no gradient, which is pretty much what we'd expect. Now, one thing I thought I had was more maybe there's an issue with timing. It's sort of taking calibration images while the shutter isn't completely closed. But we can try that by, if we leave it closed and then wait till we see it doing a calibration by the display looking less grainy, then sort of opening the shutter a bit late. We should be able to eliminate that as an issue. So if we wait for a cal period, so there, I now open the shutter. Now we've still got the gradient after the shutter's open, so I think the only conclusion really can be that it's the lens, which is letting in, the actual transmission of the lens is uneven. Whether it's a matter of perhaps the lens isn't quite centered properly according to the sensor, that's about the only scenario I can imagine. But certainly you can see fairly consistently that certainly, the closed shutter we're getting a flat field. As soon as we open it, we get the gradient. Now, of course, this lens is glued in. I assume they use some sort of jig to assemble it all, and then get the adjustment right, then stick the glue in place, presumably something like a UV cured glue to get a quick set. So I think it's probably time to take this lens holder off, which I appreciate may well screw up the alignment, but hopefully we should be able to sort of move the lens around and see what effect it has on that gradient. I'm quite curious to look at the sensor in more detail anyway, and I've got another one of these coming hopefully, so let's go for it. Now, one possible issue with this, obviously the obvious approach is just to try and crack this off. The glue's quite hard, so it's not really that amenable to cutting. I've got a few little bits off, but it is pretty solid. It's like a sort of epoxy. I'll probably try to take a little bit more off, but the issue is that because there's some glue around here now, if any of that glue has made its way to the bond wires, and if I crack it off and the glue comes with it, it may well take one of the bond wires with it as well. So I think what we'll try and do is maybe cut away this little bit just so I can see inside, just to see if there is any glue on the bond wires before doing anything else. Well, that's the first surprise. I assume this casing was plastic, but it looks like it's metal. Right, I can now see that there isn't any glue on the bond wires, so I'm just going to try and just crack this off. There we go. That's interesting. It looks like some sort of residue sitting on top of the sensor. There's the little bits of dust from when I was machining the case away. That looks almost like a sort of finger mark or a residue from glue or something. It looks like maybe a little bit of glue's made it in far enough, and can't quite see that's clearly some of the paint that's come off the inside of the lens. So whether that's just got a bit of glue attached to it, or maybe the paint was still wet when they put together, I don't know. And you see there's a total of 18 bond wires from the centre down to the PCB. So it looks like this is a sort of sandwich construction. You've got a die at the bottom which will have the vanadium oxide either deposited directly on the die or as a separate layer. Then you've got this sort of like a cap with a vacuum cavity in the middle of it. Looks like there's 3 components there. Looking at the sort of thicknesses, could be that middle one is just a spacer. So as these things go, it's a very small die. It's about 4 by 4 millimeters. And obviously that's how they've managed to get the cost down, because they get lots of them on a single wafer. And also, you know, without any additional packaging, it's just blobbed straight on the PCB, so that saves on packaging cost. Now, looking inside the lens, it does look like there's some sort of contamination on the inside of the lens. So I wonder if maybe that's some sort of byproduct of the glue, and I wonder if maybe that's what could be causing this issue. Right, so I managed to clean that up a bit. I just used a sort of stretched out cotton wool bud and some just electronic cleaning solvent spray and a blow duster to blow it all out afterwards, and it looks like it's certainly quite a lot cleaner than it was before. So let's see if that makes a difference. Right, so I've put the shutter back on. Let's see if we can actually get this lens in a reasonable position. Let's see if we've still got a gradient. Now we've cleaned it. Right, so I've managed to glue that lens on sort of, I think, fairly close. It seems to be reasonably well focused. So now we've still got some gradient, but I think subjectively that looks quite a lot less. It's about sort of 4 degrees. One issue I did notice is I think you get a little bit of light coming into the side, so if you wave your finger sort of towards the side, even when it's sort of hard up against the table, I think there is some possible effect there. Incidentally, I think the reason this is painted white is just to reduce the emissivity of the metal so that it picks up less infrared from the actual lens housing. Right, so with the lens cleaned and sort of glued back on, doesn't really seem to have made a lot of difference, so that lens contamination doesn't really seem to be an issue. Something else I wanted to try is wait till it gets dark and look at the sky. So we've got a very low background temperature, and here we're clearly seeing a gradient of about sort of 10 degrees or more. So it's not dependent on the orientation. We've always got that sort of hot band at the bottom showing about sort of 12 degrees, whereas the rest is at sort of around 0 mark. So there's definitely something going on. So what else might be going on? One possibility is, I mean, clearly what we're seeing is, there's some non-uniformity in what it's seeing when between its shutter closed position and the shutter open position. Now, one possibility could just be that the shutter isn't quite opening far enough and there's still part of the shutter still in the image. So what I'm going to do is just try and grab hold of the shutter and sort of give it a wiggle when it's in the out position, just to see if we see any change in the image. And if firstly I'll just try pushing it in a little bit just to see how far I have to push it before we see any change. I'm having to push that about 1 millimetre or so before I notice a change. So I can't really see it on camera. Let's see if I can pull it out a little bit further from its rest position. No, putting it further out doesn't really seem to make any difference. Okay, let's see if we can just eliminate the shutter completely. So I've taken the shutter out, I've replaced it with just a small piece of black plastic. I've verified that it's in the right position, it can't see anything at all through the lens. I've left it for a few minutes just so that the temperature's nice and stable. So what I'm going to do is I'm going to wait for it to calibrate, then I'm just going to pull that out. So it should calibrate against that plastic and then show us the image through the lens with no possibility of any shading or anything from the original shutter. Let's just see what happens. So I can still see when it's trying to cal just by the sudden drop in the noise on the display, so I'm just going to wait until I see that. Bang. So it's clearly, we've got a clear gradient there. It's definitely either the lens or the alignment of the lens. There's some non-uniformity across the field of view through that lens, no question about it. Okay, looks like we've had a minor collision with the bond wires, but so far seem to have got away with it, still working. I'm not going to even attempt to straighten those out, I'm just going to leave them and try and avoid hitting them again. One thought I had just to sort of investigate this lens was to actually try and stick it on the E4. The problem is, even after I'd sort of taken the casing and everything off, I can't get it close enough because this is obviously meant to sit around the outside of the sensor. The sensor focal plane is actually inside here. But while I had it apart, I thought I'd just do a quick side-by-side comparison of the sensor sizes. So you can see the Seek one is sort of very substantially smaller, and its resolution, it's only about sort of a quarter of the resolution, but it's a lot less than a quarter of the dye area. Right, I've got the lens just placed on the board. I cracked off all the glue. I folded the base of the lens down a little bit, so it's basically freestanding on there, so it's quite fragile. But after some playing around with position, I think I've got one position where if we put a flat field in front of it, we get much less, and that's 0 to 1 degree variation now. So one other thing I did do on this one, I'll try taking it off and see if it makes a difference. I did put some, I'd ground out the inside of the lens holder a little bit just in case, partly to get rid of the glue, but also I'm noticing that paint on the side of the sensor. I wonder if the adjustment position was like hard up against the sensor, so I've ground that out a little bit to give a bit more adjustment range. And because that left a silver finish, I've put some black marker on the inside just to reduce the amount of reflected light, but that's now seems to have pretty much lost all the gradient with one particular lens position. Problem is some of the lens positions jam the shutter, which doesn't help. I just left this overnight just to cool down so it's sort of completely stabilised to its sort of the original state, and say with this lens this is now showing a pretty even flat field. There's a tiny bit of shading, but I mean nowhere near as much as original, so I think it does pretty much conclude. I can pretty much conclude that the issue is lens positioning. So it'd be interesting to see what other units are like, whether there's some systematic issue in their production process, like maybe the glue shrinks or something over time. But okay, it's a cheap thermal imaging camera, but it seems like the the production process isn't as good as it could be.